Good afternoon, everyone. I'm Shaoli from Datang Telecom, China. It's my great honor to preside this panel. Actually, I started the 5G work from year 2012, so only 6 years passed. But from my side, I think 5G is developing very fast. For example, we have the vision and the requirements ready in year 2014, and we have the technologies focused in year 2015. From year 2016, we started the 5G standard work. And at the present stage, we know we have the 5G technology trial and pre-commercial stage. Now, more and more organizations have issued their plans or their results on 5G test results, and also the pre-commercial plans. So, to know the detailed or the concrete test results, and also know the non-lessons from 5G, here comes the exciting panel, 5G trials and pre-commercial launches. Here, we have totally 6 speakers. We have 2 steps. First, I'd like to invite our panelists to show their presentations, and then we will have questions. The first speaker is Dr. Yukihiko Okumura. He comes from NTT Docomo, and he is also the leader of a 5G trial promotion group of 5G MF. Please. So, the slides.
Okay. So, good afternoon, ladies and gentlemen. I'm Yukihiko Okumura of NTT Docomo, and I work as a leader of the 5G trial promotion group of 5G MF. And it is a great pleasure for me to give my talk this session. Today, I'd like to talk about recent activities on 5G system trials in 5G MF. So next.
I think it's on the podium.
Oh, sorry.
Okay, sorry. Okay, thank you. So, in January of 2016, in order to promote discussion of 5G system trial concepts and its feasible plan, the 5G trial promotion group, that is 5G TPG, was established in 5G MF of Japan. The number of TPG members is over 25, including widely kind of members that are operators, vendors, and universities. So for promoting 5G system trials that 5G MF members mainly perform in Japan smoothly and efficiently, 5G TPG continue to carry out the activity that are 3 major items. First one is collecting and sharing information on international 5G trials, including latest information from global 5G event. And second one is announcement of activities and outcomes of 5G members trials to outside. And last one is exchanging information and collaborating with foreign 5G promotion forums. Okay. So next I'll talk about recent activities of 5G TPG. For announcing outcomes of 5G system trials in Japan, 5G TPG published open booklet, the first report on 5G system trials in Japan in March of this year, and its revised version has been issued this month. This report consists of two major sections. In the first section are the possible projects or candidates of 5G system trials. More than 40 5G utilization projects were proposed by 5G TPG members, and each project includes trial concepts, content, and plans. In the second section, the latest information of 5G field trials led by MIC of Japan in 2017 is introduced. And contents, plans, and outcomes of 6 trial groups described respectively. And a few days later, you can refer the detailed contents of the booklet on the 5GMF website. But I'd like to briefly introduce the latest outcomes of each field trial in the following some slides. This is an overview of MIC 5G field trials in 2017. And these are, there are 6 groups of field trials that are categorized into EMBB, URLLC, and MMTC. Each group is led by major Japanese mobile operators and research organizations. And each group has some related partners or stakeholders in vertical industry. So now let me introduce content and outcome of each group. And this is group 1. Group 1 performed trials on ultra HD video streaming, advanced security, remote medical services by exploiting EMBB technology. Ultra HD 8K videos were instantaneously transmitted by 5G, and the group succeeded 12 channels 8K video parallel transmission. And HD video transmission is also very important to realize safety and security by using face recognition by 5G. In the trials on the remote medical services, a medical university was connected to local medical clinic. And by a 5G network, doctors carried out remote real-time diagnostics by using 4K telecom conference, in addition to transmission of diagnostic videos from ecosystem and 4K close-up camera. And second, group 2 performed the trials on entertainment for high mobility environment transportation. These trials were conducted in the motor racing circuit and railroad to achieve high mobility over 90 km/h. In the railroad trials, by using special train 5G high bit rate transmission capability for high mobility was verified. And over 2 gigabps data throughput was achieved in the 28 gigahertz band, and 4K, 8K videos were also played in the train. Group 3 performed the field trial on remote operation for construction machinery. In Japan, quick relief from disasters and recovery of social infrastructure are very important. And one example of solution is instruction of remote operation for construction machinery. In this trial, required time for moving 3 blocks by construction machinery was measured to show improved operability by 5G URLLC, and sorry, okay. And this is for groups 4. This trials on entertainment and in Stadium, Ultra HD video streaming, and ensuring station security by exploiting EMV technology. And last, this group 5 also trials on pro-tuning vehicle and remote operation for track by exploiting URLC technology. And last one, group 6 trials on logistic and smart office by exploiting MMTC technology. So this concludes my presentation. Thank you very much.
Thanks, Dr. Yukihiko Okumura, for the content of Japan's 5G trial. The next speaker is Mr. Brian O'Shaughnessy. He's the SVP and CTO of Converged Networks, Shaw Communications. Please.
Thank you very much. Yes, today what I'd like to do, if I can get my slides up, is speak to how we're approaching the 5G journey, decisions we're taking today, and actions we're taking today, as well as trials that we've just completed. Actually, they just concluded last week. Let me just, while we find the slides, let me explain who, first of all, who Shaw is, because it's not a common name for around a venue such as this one. Shaw Communications is one of the largest cable companies in Canada and operates cable, internet, direct-to-home satellite coast to coast, actually, in the country, and recently entered. There should be slides in there somewhere. Okay, thank you. To just finish off that the comment, then, and Shaw also purchased Wind Mobile, which is now branded Freedom, which operates an LTE network in the major provinces of Ontario, Alberta, and British Columbia in Canada, and also has as a unique piece, and I'll talk about this a bit more in a minute, a very large Wi-Fi hotspot deployment of over 100,000 units across the western portion of the country, and that'll form a significant basis for where we're going as a company as we enter into 5G. And hopefully the slides will show up. No, they're trying to find it. They're just trying to find it. Well, I tell you what, let me continue talking about it. The really important slides from a visual point of view are the last ones about the trial, so we can just keep things moving while they find the slides that were given this morning. The way we're looking at 5G, as I said, is a journey, in the sense of this is not a point in time in the future where we're suddenly going to turn off our 4G network and turn on 5G. We are working today. And if you think about where you need to be on a 5G network, you need to be getting to 10 gigabits per second of throughput. We've had lots of discussions on that today. What that means, again, is you need wider channels, you need higher frequencies, more spectrum assigned, et cetera, and basically very high density traffic locations. And one of the things that we're very focused on today as a company is deploying small cell technology out to these many locations in preparation, not only to meet our service needs today, but in preparation for where we're going with 5G in the future. And the 100,000 Wi-Fi hotspots I spoke about will be a key part of delivering that. Aggregation is going to, there we go. Aggregation is going to be a big portion. Here, we'll just fly through there. As you get higher and higher speeds, that requires much more significant backhaul capabilities, whether fiber or DOCSIS. So we are hardening our network today and improving our backhaul requirements today to meet the needs of our current customers as well as prepare for 5G. Much talk about low latency activities and capabilities required. That requires you to move functions closer to the edge, mobile edge computing that we talked about, And that can go in our cell site combinations, or quite frankly, we have a large number of cable hubs, and we will take advantage of those to put compute at the edge where people need to use it and take advantage of that. The services requirements are wide and varied. We've had many, many discussions today, and this diagram from the standards group kind of hints at all the various combinations that could happen. It basically requires us to have a very different architecture deployed for network slicing and virtualization. So one of the things we've done as we implemented our LTE network recently is implemented a complete virtualized core for both our 4G and our 3G and 4G capabilities, and that will be extended to 5G when the time comes. And then IoT services, a lot of discussion around the fact that you need broader coverage, and low-band spectrum coming along now is a really key part of delivering that broad coverage. So these are all, and in Canada, that spectrum will be auctioned off in the in early 2019, being the 600 megahertz spectrum. So these are all pieces that are building up. But what's really interesting is while we're waiting for technology and building the network pieces I just talked about, we're also trying to learn from trial activities. And we just completed a trial in Calgary. It actually wrapped up last Friday, so just in time trialing, if you will, for this panel. And fortunately, it worked, so I can present some results. And it was done in combinations with Cable Labs, Nokia, and Rohde & Schwartz. And it's a first of a series of activities that we'll be taking advantage of and trying to continue to push the bounds and learn more and more. The specifications, as you can see, it was the 5G TF technology capabilities, 400 megahertz of 20 gig spectrum was deployed. And specifically, if you want to just moving to results then, this is the campus where we deployed. It's one of the office campuses operated by Shaw in Calgary. We put 28 gigahertz antenna on the extreme right-hand side on one of the buildings, and then we had about 100, a little over 100 test points, both on this map and off, where we went around and looked at both line of sight and non-line of sight. Obviously, the line of sight is the yellow dots. And you can see the kind of results we received. So right out to about 400 meters of line of sight, we were getting very consistent 1 to 1.5 gigabits per second of speed, and you can see the signal strength as you move to the edge. They actually went down the road at the top a further 400 meters through a line of sight, and that's where it dropped into really more a typical 300 megabits per second, but somewhere between 0.1 and 0.5 gigabits. So you could stretch that far, but obviously the speed drops drastically, and it's a very big, rapid drop-off. And the non-line of sight capabilities, as noted here, were typically 0.4 to 0.5 at a 100-meter test point. What's interesting is when you leave testers alone at night, they find ways of doing these. They happen to be in a hotel to the right of this picture, and they had a hotel room facing the building. So one day at the end of the day, they flipped the antenna around, pointed at their own hotel, moved the equipment into the hotel room, and ran a through-the-glass test through a double-pane glass, and they were getting, it's about 146 meter range. They were getting very consistent 1 gigabit per second throughput rates, which was very, very good performance, and they did return it in the morning. The other thing, and so I was sitting down with a number of the testers over dinner at the end, and I asked them sort of, what's the big aha that you got out of it? And that's can only happen over a dinner. They said, big things come in small packages. And what it really came down to is the 28 gig performance was very, very good, largely because, as most people know, of the antenna array that was put in place. And so it was a 512 element massive MIMO antenna array that actually allowed us to keep very consistent and steady performance with the pencil beam, I'm just wrapping up now, pencil beam performance. So it worked out very, very, very well. And the only thing I would say on that that's very significant as it relates to this, and there was a question earlier about why aren't we going to similar type technologies at low band? Well, as my head of deployment likes to say, we're trying to right now put refrigerator doors on towers with, in the mid-band spectrum. And if you tried to do the same at low band, you'd probably have to put a barn door on a tower, which isn't going to work too well. So the real advantage of millimeter wave technology is being able to pack so much into a tight package and actually get way more performance than you would have had otherwise. So with that, I'll pause there and pass on to the next speaker.
Thanks, Mr. Brian O'Shaughnessy, sharing us the 5G trial results in Canada. So the next speaker is Mr. Yunsoub Shin. He is the professional manager of 5G network strategy team in LTU. Please.
Yeah, thank you. Thank you for your invitation to global 5G event by 5G America. I'm Shin from Didier Bourse in South Korea. And I'm in charge of 5G network strategy. So I'm excited to share some great trial and pre-commercial information. And I will be discussing today about 3 topics. It is 5G use cases and trial results and 5G network architecture. So, okay. In 2011, we commercialized LTE and other competitors. So this slide shows the result of the launching LTE first and focus on the LTE until now. So we have good financial conditions and loyal customers and multiple quality vendors. So our service revenue has increased steadily every year, and compared with others, we have a higher ARPU and more subscribers than other competitors. So I think this is a very positive signal for moving 5G, because we will clearly demonstrate that loyal subscriber for using the real unlimited data plan subscribers are going to transition to the 5G subscribers. And you have for access vendor. As such, you can compare vendors' equipment specification to other vendors and increase the technical equipment. It is encouraging technical competitiveness. So it is a good and useful test bed for moving 5G. Initially, we had 2 concerns for planning for 5G, for planning of 5G strategy. They were frequency and network strategy. First, the frequency auction will begin next month, but we absolutely need enough bandwidth for 5G service. But we have had some questions. What's the coverage for each frequencies, and where we must use these frequencies? Through trial, we were able to confirm that sub-6 GHz will be for the nationwide, and above 6 GHz will be for hotspot usage, such as downtown and sports stadium. So, second, we need a plan for migration. So we have 2 options for initial deployment. It is SA or non-SA. So you choose the non-SA because you want to focus on the competition in Korean market. And simply, NSA option, NSA standard was fixed earlier than SA. So we can commercialize for 5G early next year. So in this slide, we can see that international operators must select one among these typical options for 5G migration. The figure on the left is option 2, it is SA, and the right side is option 7. But we choose the center figure, it is option 3X, and then next to SA. We are going to install a new G-Node B equipment and upgrade the transport equipment to support larger bandwidth for smooth migration. So we kicked off our trial in Gangnam in Seoul. So the reason we choose this downtown area is due to heavy data traffic, and we expect 5G to be realized in there later. So we designed inter-site distance is from 100 to 150 meters, and installed the 5G antenna and DU in the LTE core location. So this result is download speed 20 gigabps with dual connectivity with using 3.5 GHz and 28 GHz. And we had other proposal for the 3.5 gigahertz and 20 gigahertz. 3.0 gigahertz is for the nationwide. So we are focused on the non-line of sight and line of sight for wide area coverage. And 20 gigahertz feature the directional beaming. So we focus on the penetration loss testing. So it's hard to penetrate the concrete building and tinting window and even foliage. So finally, we have prepared trial based on the 3GPP standard from this year. This is our slide. We have prepared B2C and B2B use cases. Many professionals predict that 5G B2B business growth rate will increase rapidly, but we cannot ignore the B2C subscribers because they use much more data traffic than B2B subscribers. So it's not easy. It's not easy beyond the B2B subscribers. So and when we analyze data traffic, so video and streaming have especially high data volume usage. So we created a differentiated video service, including interactive sports and AR, VR experiences. So especially also mobile, baseball mobile application is popular in South Korea. So I think this is a killer application in 5G. And
So 1 minute.
you can choose view such as sync view and omni view and time slice and using just a touch screen. So mobile data use and data traffic continues to increase. And we have executed project and service such as smart drone, intelligence service camera, and remote operations by securing one core technology in these particles. Thank you.
Thank you. The next speaker is Professor Luciano Mendes. He is the research coordinator of a Radiocommunication Reference Center in Inglaterra and the coordinator of the Research Commission in 5G Brazil project. Please. Oh, sorry, I have the wrong order.
Okay, that's fine. Thank you for the introduction, and I also would like to thank 5G Americas for organizing this nice event. So I will talk a little bit about what we are doing in Brazil in terms of trials. As Mr. Gontijo said already this morning, we are really concerned about the long-range operation of the 5G networks and how you can include this scenario in the 5G standard. So, let's press here. So we believe that it's possible to include a new operation scenario in this 5G architecture, introducing the concept of the supercell. So you already have the small cells operating in 26 or 28 gigahertz using massive MIMO. You also have now the 3.5 gigahertz that allows for the macro cells, which can be used to coordinate the small cells and also to provide connectivity in a larger range. And we still have the 700 megahertz or vacant UHF channels that can be used for the supercell, where we were aiming to achieve at least 50 kilometers of radius. And with this coverage, we can provide a nice set of new services that currently is necessary in countries that has continental size, such as Brazil, China, and USA, and other countries like that. And we can use that for agriculture, business, and we can use that also for monitoring disasters. We can use this network for road service, and such a set of new services that can enhance the capability of the operators to profit with this new network. So in order to allow this test, you had to build a new transceiver And this transceiver needs to have some features in order to accomplish with the demands of such a network. So what you need to have is a very robust system. So you need to use new waveforms that can enhance the robustness of the system. We are also using polar coding for the data channel protection as well, not only for the control channel, but also for the data channel. The benefit of the polar coding is the enhanced protection and the low complexity on the receiver side. So you can improve the range without improving the power, and still have a low complexity on the receiver side. You also needed to use a flexible platform for the implementation, so you're using an SDR approach. This allows us to change the parameters of the transmitting waveform, and also you can change the channel that you're operating on the fly. And we need to coexist with other services, so you need to have a very low out-of-band emission waveform, and that means that you don't need to have RF filters to protect nearby TV stations or other services. You can manage to have everything inside this box and change the parameters by using software. So you start your trial with a laboratory test. So here what you can see in this small video is the coexistence of your system with the ISDBT, which is the TV system in Brazil. And when you change it to conventional system, which uses OFDM, you can see now that the video got blocked with the out-of-band emission. So low out-of-band emission is essential to coexist with the systems that are already deployed. And so here I have a nice picture of it. So you can see now that you're using GFDM in this case. You have a very low out-of-band emission. And once you turn to FDM, the system crashes the ISDBT. So that's why you're using these low out-of-band emission waveforms. I might come back to the presentation, please. So in terms of, with this approach, we realize that you are going in the right direction. So we start with the field test. So here we have a picture of the area where I live. It's a rural area nearby São Paulo. So you can see the red dot is the base station location, and the green area is where you have a nice prediction coverage. So we do not rely on the prediction, so you go to for the measurements, you put the base station here. It's the top of the hill. You're using 2 transmit antenna, 20 watts each antenna, but you're losing a lot of power because you use long cables. We need to improve that. So actually what is transmitted is 6.3 watts per antenna. You're using 6 megahertz band, and with that, in a elementary school, which is located more or less 7.5 kilometers away from the base station, you managed to achieve up to 33 megabits per second. And that's quite special because in that school, the kids do not have any internet access. You also measure it at Telecom, which is not in the line of sight. So in this case, you managed to have up to 22 megabits per second. This indicates that you need to use some sectoring in order to achieve omnidirectional coverage. And here we went for a farm that needs to have some automation, and there you managed to have 22 megabits per second. We did not measure with the other settings in this case because the weather was getting very bad and you need to remove all the equipment. But it seems that with the performance that you got with 64 QAM, it's also possible to get 33 megabits per second here. So that's all from my side. Thank you very much.
Thank you. It's very exciting to see the 5G test results for remote area, even reaching 50 kilometers. The next speaker is Dr. Didier Bourse. He is the Senior Director of European RI programs, Nokia Innovation Steering. Nokia, please.
Okay, thanks a lot. I'm very pleased being with you today in Austin. I will address what we are doing from a 5G Infrastructure Association perspective in the context of these trials and what we call the Pan-European Trials Roadmap. So we have released the version 3.0 of this roadmap on the 7th of May, and this is available on the PPP, on the Public-Private Partnership website. And this is a relatively short, concise document showing you the progress that are achieved at European level on trials. So just as a reminder, we released the roadmap synchronized with the global events. So the version 2.0 was released, and I was explaining you in Seoul in November where we stand. So a lot of progress has been achieved in between November and now in Austin. So basically what we have seen, we see more and more achievement in terms of pilot and trials experimentation done on 5G at the European level. So you know we have a very rich ecosystem in Europe. We have the 28 countries. We have many operators. We have industry, manufacturer, vendors, operator, and different stakeholders. We work hand in hand with the research center academics. And basically, in the roadmap, we review where we stand regarding the different perspectives. So clearly, the core of the trial and pilot is what we call the private trial. So basically, an operator working with a manufacturer vendor, an operator working with several manufacturer vendors in parallel to test and prototype different features, different perspectives, and also step-by-step involving vertical stakeholder. So we see, let's say, the development of both the achievement and also the enhancement in the different European countries with the different operators. So what we do is we review and monitor all the development on the private trials, and the information is made available on the PPP website. So you can see for the different countries and the different operators what has been achieved on the 5G let's say test and trials. So what is also important to stress is that at European level, and you have heard this also from Peter Stuckman this morning, there is a priority on the vertical sector. So we have a lot of effort that is done regarding the question of how 5G will help the different sector, whatever is automotive, health, industry, manufacturing, public safety, and so on, in order to really make the best for their sector. So this is also something very important to mention here. We see as one of the flagship use case automotive that is boosted at the European level between the European Commission and the member state and also the industry with specific connected automotive mobility and corridors that are also being moved forward. So this was mentioned also this morning by Peter Stuckman, both the Observatory and the Pioneer Award. And the 5G Observatory will be a very important instrument at the European level to monitor and to review the progress done in terms of 5G, let's say, deployment and commercialization in Europe. One point also to be mentioned here is that from an association perspective, so PPP, 5G Infrastructure Association, a lot of effort is done, let's say, in connecting the 5G with the different vertical sector and regarding the vertical strategy. So what I want to show you, I will not have time to go in the details, but this is explaining the strategy that is connected to this Pan-European Trials Roadmap. What is really important to understand is that basically the different blocks that constitute that are enabling this strategy are all interleaved, and we find the cities, this is an important message, we find the cities as one of the core elements, let's say, whatever it is where the pilots and the trials are executed, also where some of the platform in the different countries in Europe are available, and also in the context of this 5G trial cities that are step-by-step taking momentum. And also, as an illustration, you may know that we develop the 5G UEFA, the soccer, the football championship as a flagship event for the launch of 5G in 2020 in Europe, where it will be played in 12 different cities. So basically, the cities are core. So the development of 5G and the pilot and trials is supported by European Commission program and project, and also by specific member state initiative. This is now in few slides just some illustration of what you find more in details in the roadmap version 3.0. So this is an illustration, and you see by countries the trials and pilots that have been achieved or announced publicly. So this is based on public information, and you can find detailed information on the PPP on the association website, where you see, let's say, what ever has been accomplished or will be soon coming in terms of experimentation. Then this is just an example, like I did it in Seoul, where this is really recent announcement of what has been, let's say, demonstrated, trial, piloted between operator and manufacturer. And you see basically that in the different countries, these are tests of features of 5G. So basically data rate, latency, so the key features, but also moving step by step with vertical sector. So you see tests and trials with, in the context of industry or in the context of automotive. And you see basically this is distributed over countries and with different operators. So this is really moving fast now in Europe. This is one slide, and you can also find more details in the roadmap explaining the vision of the strategy for the different vertical sectors. So the idea is really to work hand in hand with the different, some of the key associations in the sector in order to really discuss the use cases and see how 5G can benefit. So just to spot in the automotive sector, of course, the 5G Automotive Association, or the EATA, the European Telecom Automotive Alliance. And you may have heard also recently, for instance, in the context of Industry 4.0 and manufacturing, you certainly know IIC, but the recently announced, and also with a specific session during the Hannover Messe in April, this 5G Asia, so this Alliance for Connected Industries and Automation.
30 seconds.
Yeah, I'm coming to an end, thanks. And here, this is my last slide, just explaining you also that the PPP, the public-private partnership, the phase 2 today, is already a strong support to the development of pilot and trials for 5G. And this is just a table illustrating for some of the projects from the PPP phase 2, how they contribute in specific vertical sectors, whatever automotive or smart cities or industry 4.0, and where the trials will be organized in terms of cities and countries. And in the roadmap, you can find more information on the description and focus of the trial. So that's it on my side. This is very short, but just to give you some highlights about what is happening on the European roadmap. Thanks.
Thanks. The final speaker is Dr. Chih-Lin I. She is the chief scientist on various technologies of China Mobile. Please.
Good afternoon. Well, following that kind of high baud rate, it's a bit challenging. It's a great pleasure to be here and seeing many of the old friends, some new friends as well, of course. We have heard a lot about field trials today and 5G. So I guess I'll just go right to it rather than giving any background. But still, I would like to say that the most refreshing thing I heard today was from, I think, T-Mobile and Sprint, respectively, because they were working on their unique piece of spectrum. One is on the 2.5 for 5G. The other is working on 600 megahertz. Those bands, very good bands. Congratulations to them. Some of you probably know that we have been focusing primarily on sub-6 gigahertz band, specifically around 3.5. Actually, I should say that not just China Mobile, but the other two operators in China, we are all kind of following the timeline and grand plan and the leadership under the IMT 2020 promotion group. So whatever you see here in terms of the milestone and timeline are very much in sync with IMT 2020 PG. So as you'll see that in 2016, we have completed the key technology test for 3.5 gigahertz band. And last year, we were focusing on what we call system verification, primarily in 5-6 major cities. We started putting up small-scale field trial, about 7 to 10 sites per city. In each city, we were collaborating with one specific vendors, equipment vendors. So 5 vendors in 5 cities, more or less. And starting this year, we are expanding beyond that base, probably going to larger scale in each of the cities, as well as going up in the number of cities. And more importantly, in each city, it will not be the territory of one single vendor, because it's very important to start, while we are scaling up the trial, we need to make sure the interoperability is successfully accomplished across multi-vendors. And following the current timeline, we expect we should be ready for true commercial deployment of the first stage of the 5G in 2020. As for millimeter wave band, we started a little bit later. So following the current timeline, it will probably be commercially deployed a year and a half, more or less, later than the 3.5 gigahertz band or the sub-6 gigahertz band. And it's not moving. Okay. Some quick summary of the current learning. For sub-6 gigahertz band, primarily at 3.5, our configuration of the sites is with 100 megahertz bandwidth, and of course, must have massive MIMO with 128 or 192 antennas, and 64 T64R. This is a full digital version, not a hybrid architecture. And also, for uplink, we are using what we call high-power UEs, which is 26 dBm. Okay. More or less today, the good news is, with this setup, we can meet more or less, I think, 3GPP as well as ITU's criteria for single-user data rate, as well as the cell peak throughput and average throughput, as well as the spectral efficiency targets. And as for latency, user plan seems to be okay, whether it's 4 milliseconds for eMBB or sub-millisecond for the URLLC with the current design. And a little bit challenging is the control plane latency currently. It doesn't seem to quite meet the 3GPP criteria, even though it did make the ITU target. Well, for millimeter wave, as I said earlier, we start later than the sub-6 gigahertz band. So currently, well, we did partner with maybe not 5, I think 4 vendors. Actually, these 4 vendors in this case include Samsung, I think, on this band. We are accumulating experience and knowledge. Currently, in terms of, for example, O2O, I2I, or O2I, currently the range is around half a kilometer for O2O. For I2I, I think it's 60 meters, whereas O2I is very limited, only to 15 meters. This is by no means anywhere near the system design and performance. We are just still learning about this field. I think in general we could say that we are interested and look forward to the millimeter wave band opportunity. And certainly this part, I think, not only South Korea, but US is probably the leader in getting scaled system out in the fields. So hopefully we can learn a lot from them. But we are also concerned about the cost and performance of the mid-wave band components currently. And I want to touch upon a little bit about the core network, because we know that in terms of ICDT deep convergence and transformation of our system, core network is taking the lead in going through SDN&V and also service-based architecture. And many of these concepts have successfully been prototyped from our partnership with the vendors. I think later this year, we will see both the standalone and non-standalone prototype are going to be completed, whereas we hope that it's ready for large-scale field trial. But well, the good news is with this new approach, we can see that the core network functions going from standards to prototype time is much shorter than before. It went down from half a year to now 1 month time. But from prototype to large scale, stable, reliable deployment, we believe there's still a long way to go and still a lot of lessons yet to be learned. And this page summarizes some of the main lessons that we have learned so far, but maybe we can leave that for the discussion. And this kind of summarizes our current trial. In 5 cities, it's going to be really large-scale infrastructure trial, while plus we'll have another 12 cities with end-to-end 5G service trial. And we are starting deploying this middle of this year. And one example I can share with you is our latest announcement in Hangzhou City. By July, there will be 100 cell sites set up. And by October, we expect to have 300 sites covering 100 square kilometers. By 2020, we believe we are very confident Hangzhou will be 100% fully covered by 5G. And we also think there will be many more of such cities in China that will be accomplished. Very quickly, I also want to echo about the important thing of partnering with verticals. I think we all believe that the success of 5G depending on the successful partnership with different industry and cross-domain collaboration. So our 5G Joint Innovation Center actually currently already has almost 120 partners, out of which more than half are from various verticals, which I have categorized some of it on the right half, upper right corner. And another important thing is, as we all know, every time we have a new generation, new technology, new system coming into practice, it's not just the infrastructure, the terminal availability and maturity is very important as well. So we have launched a 5G device forerunner initiative at Barcelona this year. Hopefully, together, we can meet our current target, which is go beyond FPGA-based UE prototype. And sometime next year, we will be able to see 5G terminal chips available for various terminals, because yes, it's not just going to be smartphone, right? It could be drone, it could be robot, could be mobile vehicles. So finally, I just want to say a word or two about O-RAN. This is a major alliance initiative that was launched by CTOs of 5 operators from China, from US, from Europe, from Germany and France, and also Japan. And this is going to be an end-to-end major transformation, bring in open source, bring in intelligence, AI, bring in virtualization, and white box reference design for various parts of the RAN of 5G. So there will be different strategy and different timeline for different technology introduced into CU, into DU, into RU, and integrating with intelligent control for RAN, as well as interface effectively with MEC. I think some of the talk that has been covered this morning. And if you are interested offline, you can look at the current working group in this alliance, and we certainly look forward to many more members to join. Right now, we have about 30 plus in the queue waiting to join. So that's the last page. Thank you very much.
So since time is very limited for this panel, so we only have one question from the audience. Please raise your hand.
One question. Chris Pearson, 5G Americas. I guess it's for Shaw. When you look at the 600 megahertz auction coming up in Canada, do you look at that as a spectrum that you'd use for LTE and 5G new radio, or is it? Do you look at it more like, hey, that's a blank canvas. We're going to go out. If we had it, we're going to go out there with 5G.
Well, the good news about the way technology is being developed by now, we don't have to make that choice in the sense of you can always start by deploying it as LTE if you choose to, but it's very easy to change it and flip it to be 5G. So given we have a couple of years to work through the process, if I was a betting man, I'd say we'd start with a little bit of LTE capability, but reserve as much of it as possible for 5G, and then migrate very quickly to full 5G over time.
Okay, so since time is up, we have to end this panel. Thank you very much for the panelists and for the audience. Thank you.